Lab 5, Create Your Own Adventure. For this lab, I decided to do my lab on collisions. I want to explore how energy transfers and changes during the collision of objects, and in which my case of the lab, two identical objects. After finding a video to observe from YouTube, I used Tracker to collect data of the movement of the two cards in the observed motion. Using the data from Tracker, I created a graph with the motion of the objects and wrote a code to find the ideal motion of the cards. After running the code, I compared the graphs. As a result, I concluded that the collision of the object was elastic because no energy was lost in the change in the model, which differs slightly from the actual data. Now let's discuss the physics concepts. I observed two fundamental principles of physics in this lab, Newton's second law and the energy principle. In Newton's second law, I used the principle to find the position of cart 1 before the collision and the position of cart 2 after the collision. Using the ideas of momentum, in which the change in momentum is equal to the net force multiplied by the change in time, I used the position equations shown on the screen. The positions are also modeled in the model in the graph. In the change in the energy principle, I tested the change in energy of the system, the two carts. The result could either have been elastic, the total change in energy is zero, or inelastic, there's a change in energy. But energy is always conserved, never lost. Next, I will discuss the video and the code. In the video, two carts collide. In Tracker, collected the data of the motion of the carts as time progressed. Using the collected data, I plugged it in to an Excel spreadsheet and graphed the data, as shown here. As seen, the first cart was close to constant velocity and the second cart was motionless before the collision. After the collision, the second cart was close to constant velocity while the first cart is almost motionless. While a little change from the motion of cart 1 to cart 2, I project the collision was elastic. Now in the code, I initialize the cart's masses and positions and velocities before the collision and after collision, as shown here. The delta T and the initial energy of the system. While iterating through the first while loop before the collision, I calculated the position of both carts and the kinetic energy of the system, as shown here and here. Then, I followed the same process for the second while loop after the collision. Here's what the code looks like when ran. As you see, as the block collides with the other block, one block stops. And shown in the graph, the green line represents the kinetic energy, which is zero the entire time. And as the motion shown of the two objects, the blue line is the position of the first cart. The red line is the position of the second cart. Therefore, as a whole, the model predicts the elastic collision. Here's the code and the actual data side by side. Some differences in the model and the real data are that after the collision, cart 1 completely stopped in the model, while Slows was stopped in the real situation. Some reasons for this include a slight difference in masses that could have been incorrectly calculated, as well as not taking into account any outside forces acting on the system. Some observations that proved the collision was elastic were the objects not sticking together after the collision, and there was no energy changing from the beginning of the video until the end of the video. These two characteristics of collision categorize this collision as elastic. Thank you for watching.